we are trying to just elaborate what we have said about reading of blocks in this diagram. There is a client which passes the file name onto the name node. This is trying to read. It passes the file name that it wants to read. The name node gives back the block IDs and the data node locations, data node IP addresses, for example, to the client. Then the client reads data from the individual data node. The name node is controlling all the data nodes. There is something called a secondary name node. What it does is to keep copies of the metadata maintained by the name node. Secondary name node is not a fail-safe mechanism for name node. If name node fails, secondary name node cannot take over as the name node. What it does is to periodically keep copies of the metadata maintained by the name node. So what you can do is you can reconstruct up to a certain point from the data maintained in the secondary name node, but you won't be able to do a hot swap between name node and secondary name node. This is the architecture of Hadoop as it used to be. Next version of Hadoop is looking at federated name nodes, which is multiple name nodes. We'll go into that in the last class. But existing structure is this. And in this whole cluster, there is a bus that connects all the machines of this cluster. The data nodes are connected to it, so is the name node. These are all part of the cluster. So the picture that we had shown earlier, one of the nodes there is the name node. Name node is not a special node that is separate. Okay. So we would like HDFS to be able to handle up to 10 petabytes. So that's the range of data that one is looking at in HDFS. It can have a very large number of relatively small files. I'm sorry, I've said it reverse. It can have a relatively small number of large files. Okay. What I'm trying to say is, for every file, name node will need to maintain the metadata. So if you have too many files, then the amount of metadata that it needs to keep, that name node needs to keep, is very large. That's why you are having 64 MB, 128 MB block sizes. If you allow files like in a regular file system of 5 kilobytes, 10 kilobytes, then you would put a lot of load on the name node. That is why relatively large files, which is 64 MB, 128 MB blocks, relatively large files, a very reasonable number of them, not very large number of them, is what we try to do. HDFS should assume commodity hardware. It should be optimized for batch processing. So data locations are exposed. How do you handle batch processing? By ensuring that the programs move to where data is. So your map job would just do one sweep through the whole data. Remember that the application where we are doing voter list and matching to see who all are from this city. You would just scan the data, the 64 MB or 128 MB back and block. Take in each record, either retain it or either output it or drop it based on what the location is. Walk through it. You really don't need to do any random seeks inside the data. You just do one scan of the data. HDFS works very well when you have such batch access of data instead of having to access random locations inside the data. And a lot of applications, you'll be surprised at how many applications make themselves amenable to such block reads. For example, the entire log processing applications are amenable to this. Text, search engine index building is amenable to this. Image processing, video processing is amenable to this. HDFS should run on heterogeneous space and it should run in user space. What we mean by this is The HDFS daemons have to run on the local machine. The local machine anyway has its own file system, right? One local machine may be Linux, another local machine may be Windows. Your HDFS daemons will have to run in the user space. I have said this before. Replicas are stored on different nodes after replicating it 3 times. HDFS is strongly based on Google file system. For those of you interested, I could share. I'm not sharing it in the class because it's a little outside the scope here. But those of you that may have worked on Google's file system and want to know the differences between GFS and HDFS, I can give you a document which discusses that. A modest number of large files. It performs best with that kind of millions of files, which is a modest number. Each one of about 100 megabytes size, 64 to 128 MB size. Does not allow random writes and is poor at random reads. It's optimized for large streaming reads and write ones.